Good evening, everyone. I'm going to talk to you about a little bit about safety when it comes to working with live circuits. But particularly, this is a GFCI that had failed. It had failed badly, but that, well, hold on. So here's the. Hold on, I'm trying to get the button back into its socket. Hold on, yeah. Yep, there we go. Here's the faceplate off that particular GFCI that had failed. As you see, there's no burn marks of the face. The button's still there, pretty much. I do have a pretty much similar one right on that side. I think this is a reversed video, so this is my right. This is what looks like my right hand is my left hand. So, yeah, as you see, the words on my shirt are backwards. I'm using the front-facing camera on the S8. S8 Plus. This is the faceplate of the particular GFCI. Here is the yoke part of the GFCI that I had replaced. It was a live circuit. Don't attempt to work on live circuits unless you know what you are doing. I have some experience working with live circuits. I have been shocked by live 120 volt current. It's not fun. It actually hurts. I don't know if any of you have been shocked by those giant flash capacitors in the old picture cameras. I've been shocked by those. That's 300 volts. That stuff makes you freeze and it hurts. So, I'm going to teach you something. This is a GFCI right here. I have this on my little model here. You see the hot wire, the neutral wire, and on the bottom is the there, the green ground wire right there. This is a little mock-up model I made for examples. Plug this in the wall and then you can show them blah blah blah. But in behind this cover right here, this back cover, take out these screws here. I have the screws from that particular GFCI right here. There is a circuit board under here that looks like this. This is the one from GE. That circuit board is what tells this when there's a fault, and also when you test it. So, put this back in. The circuit board tells the GFCI that there is a fault in the system. So, like, if this was your kitchen, your house kitchen, they'd be facing like this. If you had a professional do it, it'll be like this, per se. So if it was like mounted like this in your home and you had the thing sticking out like this, something drops on here, it will trip your GFCI. If the circuit board has failed, which in the case of the one right here, it does not trip. The safety circuit board inside the controller has failed. So it does not trip when you push the test button. So it's no longer considered GFCI. It's actually considered now, how I'm using it, it's a normal outlet. But inside there is a circuit board. I think you can see that. Block some of that light. Yeah, there we go. Inside there, there's a circuit board. You can see the controller chip, the control chip, some of these components. But if you notice, it is black. Even in the back, it's black. It's charred. I have a little surprise to show you guys that if you look at this trace right here, this circuit board trace that goes to this high voltage coil, something, I don't know, when I pulled it out, it literally went pop. So, see this trace right here. This trace is blown out. So something happened to the trace on the board that made it fail very, very badly. So it failed completely. So this unit is pretty much toast. That's why I took it apart. But typically when they fail, this does not happen. But something happened to cause this trace to go kaboom. So just be in mind, this is what protects and makes the GFCI work. Arc fault circuit interrupters are a little bit different, particular style of concept of a GFCI. AFCI, this time the AFCI works differently than your GFCI. Your GFCI is just sensing the current that comes through these holes right here. It's backwards, so your neutral, your hot wire. Neutral and hot. Neutral, hot. And then your ground, your center grounding pin. The AFCI sends a constant monitoring signal through the run that's down the run. This was first in the line. This was an AFCI. This was first in the run. You go down the run to your next one. The next one, when you wire it in, you have two terminals on the back, typically like this. Normally, I've seen them. The load wire, the load is on the line is on the top. The load is on the bottom. The load wire, the line wire, is where your incoming power comes in, right here. This is the line wire here. Then the load wire is where you'd hook up your next branch in the circuit, which would be the next one in the circuit, which would be a normal outlet, or I guess you could hook up another GFCI in circuit, but if it is already GFCI protected, you don't have to. You really don't have to. There went the button. Oh well. So pretty much it failed. It's bad news bears for this one. But the signal is going through the wires, through this one, through the next one. You can have up to 4 on, I think 3 on one circuit. That'll be AFCI protected. Then you have to install another one if you want to make another branch down the line. So yeah. So with this one, it just went completely, it went complete kaboom. But the AFCI is just sending a signal through the wire, sensing for arcs. If there's any arcing in like, not the ground, it's not I don't think it's sensing the ground, but in your neutral and your hot line, there's a signal being sent from the neutral, from the white neutral to the black hot, down to your second circuit in the line. That it's constantly doing this, no matter what. It's constantly doing this signal, making sure that if there's any arcing between the hot, it will cut the circuit. It will trip, and you must find out where it's arcing. If it's a loose connection on your outlet, or a busted wire. And just to let you know, under any circumstances, if you don't know what you are doing, hire a professional licensed electrician to do your work on here. But if it's a frayed or damaged wire, hire a professional electrician to do the work. Safety. It's your safety that matters. The electrician safety also matters, but your safety really matters. So work safely if you're going to attempt this type of repair yourself in your own home. So please take it into mind that safety is all about safety. And to put it that way, I take no responsibility for any means if you get hurt attempting a repair, such as an outlet replacement or a GFCI replacement. I take no responsibility whatsoever for your problems. In other words, I'm not being held responsible if you get hurt. Thank you very much for watching Electrical Safety.